Thank you. So I use the term that everyone hates. I use the I word. So we can go ahead and change it to universal flux if you want. Or we can just call it what it really is, flux shared on the server and on the client. So let's just get straight to the point. Actually, let's talk about, so who am I? I'm Michael Ridgway. I'm a front-end Node.js engineer at Yahoo. I work with teams at Yahoo who are adopting React and the Flux architecture. And I also work on an open source library called Fluxible that aids in our developers building these isomorphic applications. I also did a presentation at React's San Francisco meetup on this subject last year, and the slides have received almost 200,000 views, which is crazy. I was also part of the Flux panel at January's React conference. So at Yahoo, we build a lot of apps. We do pretty much everything. And all of these apps can be wildly different. We have the Yahoo homepage, which is a portal to other applications, a newsreader, and a conglomeration of other information, like weather, sports, etc. We also have interactive fantasy sports applications. And these also contain real-time data flowing from real sports games. And then, of course, we have Yahoo Mail, which is complicated in and of itself. Now, not all of these need to be rendered on the server side. But we do want the flexibility to render some of them on the server side. And I'll show you what I mean. So if you take the Yahoo homepage, we want to be able to present on the server immediately the information that's useful to the user. For bots, we want to render the full page so that SEO is taken care of. And in times of high load, it may be beneficial to disable server rendering and just give it to the client and have it render it itself. So why do we need server rendering anyway? I already mentioned SEO. We know Google does execute JavaScript, but it's hard to know what it's going to look like to the bot. You also get free legacy browser support. So if you don't like supporting IE6, render it on the server, give them just a straight-up HTTP experience, and it'll still work for them. They can still see the content that they want to see. And the biggest one is user-perceived performance. Getting the information right in front of the user can actually impact the bottom line and how much money you're making, because the user will actually stay on the page longer and also visit more pages. So when you're building a single-page app, you need to think about whether you need to render on the server or not. Most of you, maybe you don't, but there are cases where you do want to. And if you do, you want to share as much code as you possibly can. This is the ultimate in developer experience. So looking at your stack, you may have two different implementations, one on the server, one on the client. You might even be using a different language on the server, PHP, Java. And the client might have its own MVC system. It may not do routing, but it may do other complicated things like JavaScript interactions. And then you may find some library that you can actually use both on the server and the client. For us, it was a view engine. About 2 years ago, we started doing Node.js on the back end, or on the server side. And we were able to use just.js both on the server and the client. And we were able to compile that down and have rich interactions on the client using the same templating system. But there's still a gap. We had all this other code that we wanted to share, but we just couldn't. There weren't a lot of libraries out there that actually do server rendering. I mean, if you look at Ember, Angular, none of them actually do that yet. So the ideal is to get to this place where all of your business logic, routing, views, and data fetching can all be done both on the server and the client. This is like the holy grail. And then you have like a small slither of code that maybe bootstraps on the server and also bootstraps on the client. So let's take this stack and let's propose some actual libraries for it. Of course, we're all here. Maybe we should use React. It's up to you. React gives us server and client APIs. So on the client, we can call react.render, and we just put into a DOM element. On the server, you call react.render to string, and you get back a markup string. So we'll fill that in. You've already heard from Michael Jackson today about React Router. Again, provides APIs for both the server and the client. Now this next one, I just chose this because of the icon for it. I don't know why they have it. But SuperAgent is a data fetching library that gives you the same API both on the server and the client, so you don't actually have to change any code at all. If you're using Browserify or Webpack, you can call the same thing and it'll work. Now there's plenty of other libraries out there for this. There's Isomorphic Fetch. Soon we'll be able to use Relay. So we're left with one little piece, and something that ties all of this together. And that's where Flux comes in. It handles data changing over time on the client, provides clean unidirectional application flow, describes where state management happens, which is in the stores, and decouples model dependencies by using event handlers. And we all know the typical Flux diagram. So the question is, Flux is for the client, right? If it's for single-page apps, does it actually make sense on the server? Well, what I'm trying to say here today is that Flux is really lightweight, and you can use it on the server. You can reuse the same actions, stores, and the other pieces of your code on the server and render your application and give a good user experience. If there's any confirmation of the fact that Flux is pretty lightweight, you can just look at all the wealth of libraries that are out there that re-implement Flux in their own way. And there's not a lot of code to them. Usually it's just a central dispatcher and then some other code around it. So if we can use Flux on the server without performance issues, why wouldn't we reuse that code? So let's go ahead and fill it in on our stack. And then let's go through a proposal for a Flux server flow. Now, there are variations of this pattern out there. There's a lot of libraries. I can't go over all of them. So what I'm going to go over today is one of the more typical ones for server rendering. Yesterday, you saw Dan Abramov's Redux, which is more a functional Flux with stateless reducers and a single stateful store. We also saw Flux over the wire, which is more stateful Flux, where servers are actually sharing the same state with multiple clients. But what we're going to talk about today is taking the stock Flux concepts and make it work for a concurrent environment on the server so we can render personalized applications without leaking data between requests. So the ultimate goal is to render your component. And the first thing that you realize when you want to render on the server is that you don't need to render prior to loading your data. You just want that final markup. So we'll just wait until we have all of the state in place before we call React Render. The component, of course, gets its data from the stores. And the stores receive data events from a central dispatcher. And those events are called from an action creator. And this action creator can be asynchronous. And this is where the issue actually arises with rendering on the server, is that you need to make sure that in a concurrent environment that the data flowing through the system actually goes to the right place. So let's take a request. And this is like the typical flow that we use. So take a request. Based on the URL, we call some action creator. That action creator will fetch some data, dispatch it through to a store, and then we'll render the component once everything has been completed. But if you add 2 more requests to the system, we'll see some concurrency issues. If we're using singleton Flux, the requests flowing through the system, we're not sure which data will be in the stores at what point. So we're not sure what data will actually get rendered to the client. So the easy solution, we can instantiate the stores each request. And this looks correct. But what you're actually getting when you do this is a dispatcher that then sends all of the events to all of the instances of the store. So it's clear we need to instantiate the dispatcher per request as well, and make it reference only the stores that are used for that request. So we'll go ahead and do that. So now we just need to ensure that action creators can call dispatch on a specific request dispatcher. And to do this, what a lot of libraries have done is they created a container for their Flux context. So you can see here, for each request coming into the system, we create a new context for that request, and that context contains a dispatcher. That context can then be sent into an action creator, and the action creator will call dispatch on that context. And then the context is passed into the component so that the component can get access to the specific stores for that request. But what about the server-client transition? So now we have an execution path on the server that keeps the request-specific data scoped to only its request, but we want to get it down to the client so that we don't have to call APIs again to get the same data. So what we can do is send both the markup and the store state down to the client. And then we can just rehydrate React on top of the existing markup. And we can actually instantiate the Flux context again on the client with the exact same state as what was on the server. And from that point on, you can use lifecycle events, or you can execute your own action creators on the client and make it work exactly like a single-page application. So now we've achieved the flexibility that we want. We can render both on the server, we can render on the client. There's a lot of possibilities here. So what I'm going to show you right now is a demo of a Flux example that we've created. We have several examples in our GitHub repo. All right, there we go. All right, so this is the typical Flux example that you see in the Flux repo. It's a chat application. And you can see here, it works just like normal. But if I look at the source, this is actually sending down all of the markup from the server. And it's also sending down the data that was used on the server to do the rendering. And the nice thing is that we can disable either one of them. So if we don't want to load on the server and wait for the client to load the data, we can send down a shell and the client will load the data itself through XHR. Or we can disable rendering and just send down the data, and that gives us a really quick bootstrap. You can see a little bit of a flash, but it's still pretty good. And then, as I mentioned before, in high load times, you can disable both and have it work just like a single-page application. You send down a blank page, it'll load data, and then it'll render the shell, and then once the data has completed, it will render the rest of the application. And I know everyone likes to do MVC, so here we go, to do MVC. And we can do the same thing. You'll see the flash that we saw before if we don't render on the server. So you can see here that as your application gets bigger, that bootstrap time will actually take longer. And that's one of the issues with single-page apps today is that you get that blank page, and then maybe 300 milliseconds later, 500 milliseconds later, then you'll see a pop-in of all the actual rendered markup. And that's time that actually affects the users. So I already mentioned there's several Flux implementations out there that can do this. I happen to work on Fluxible, which is open sourced by Yahoo. There's Flumux, there's Alt, and there's Marty.js. And all of these do a similar way of rendering both on the server and the client by creating a Flux container. There's also Redux, which we saw yesterday, which is pretty awesome. So I work on Fluxible. And we call it a pluggable container for Isomorphic Flux. How is it used? Pretty simple. You import Fluxible, you instantiate a new Fluxible instance, and you can pass in your app-level component, which is just a convenience method. And then you create a new context per request, or in your browser for each user. And from that context, you can then execute your action. And then once that is finished, you then want to render the markup. And in the client, that would be rendering to the DOM element. On the server, that would be rendering to a string. So a lot of the questions that we get are like, why does Fluxible have its own dispatcher? I already mentioned that a lot of the other libraries use the Flux stock dispatcher. And it's totally reasonable to do that. The reason we have our own is so that we can optimize for applications that grow pretty large. With the stock dispatcher, you would have to instantiate the dispatcher for each request. You'd have to instantiate all the stores for each request because they all receive the events. And you'd also have to register all of the listeners for the stores on every request as well. So Fluxible allows you to register them up front, and then we create the context after the fact. And we also have a static handlers object. And what that allows us to do is the dispatcher will know which stores will respond to a certain events. And in that sense, we can basically instantiate only the stores that are used for that current request. And so it's a little savings that we get. And that can actually translate to pretty large savings when your application gets pretty large. In our case, we're working with hundreds of developers. Fluxible also gives you restricted access to the functionality within the Flux flow. So if you're working with a lot of developers, you may have found that they don't necessarily understand Flux, and they may do stupid things like having action creators call stores, having stores call actions, having React views call actions, having stores call React views for whatever reason. I don't know why they would do that. So Fluxible gives you basically a restricted set of interfaces for each type of object. So within actions, we can call pretty much anything. We can dispatch actions, execute other action creators, and we can get access to stores only for getters. From stores, we can get other stores instances, and we can call wait for, which is part of the base Flux. And views can execute actions, and they can call get store so that they can get the data for their component. Fluxible also contains a plugin system, and it allows you to add new functionality to each of those interfaces. So you can see here we have an open source plugin called Fetcher, which basically gives you a way to generate RESTful services and then have it work both on the server and the client. So you could have a service that talks to MongoDB or MySQL, and you can access it using the same interface. You can see down here there's a context.service.read. You pass in a resource, and it'll give you back whatever the call is. And on the server, it'll just call it directly. It'll call the service just by calling a function. But when you get to the client, it'll make an XHR request to receive that data. Fluxible also gives you dehydration of stores to the client. Each store can define a dehydrate and rehydrate function. The dehydrate function should return a serializable state object, and the rehydrate function takes the state object that was passed down from the server and will fill in the state back on the client. And then we also provide at the Fluxible level a method that will iterate through all of your stores and return that full state object that can be sent down to the client. On the client, you call app.rehydrate, and it'll give you back a context that is filled with all of the stores and the data for each store. We also provide higher order components and decorators for React integration. Here you can see an example of using decorators. We have one called provide context that will basically take care of making sure that every component in your tree will have access to the Flux context if it says that it wants to access them. This gets around some of the issues of accessing the Flux instance. You don't have to pass it around as a prop to every single component. You can basically have context passed down automatically for you. We also have a connect to stores decorator, and this allows you to listen to specific stores for change events. And then you pass in a function that will take the context and the props and return the state that needs to be passed into the component. And in this case, the way this works is anything that's returned from that will be passed as props down to the child component. And this allows you to create really clean components that will receive just props. They don't have to worry about state at all. And it also hides the context from you, so you don't have to know anything about context. For dev tooling, we use Babel, ESLint, Webpack, Babel Loader. You've seen all these before. We use Grunt and Gulp. It depends on the project. We have some legacy stuff that's still in Grunt. We also use Yo generators, and we have an open source Yo generator for Fluxible that will get you set up with all of these tools. So the big question that I'm sure a lot of you are asking is it in production? And the answer is yes. We are using it in production. We have several apps already released yahoo.com/tech, which is a magazine about technology. We also have several other magazines that are using the exact same application structure. We also have mobile websites in Taiwan that are using Flexible as well in production. And we have several other products in buckets or in A/B tests that you'll see coming out releasing in the next few months. So are we there yet with the holy grail of developments? I have to say, not quite. We're getting close, but it's hard. There are still some issues. The first one, data dependencies for your components are still not easily known. And Relay will help with that. Being able to know which component is on the page will allow you to statically analyze and know all of the GraphQL queries that will be used for fetching all the data. And you can do it all in one call. So I'm really hopeful for that to fix some of these issues. Another issue is that React server rendering right now is rather slow, unfortunately. But I'm hopeful that with React 14 having a separate server rendering path, we'll be able to go in and optimize that and remove some of the stuff that isn't used on the server, like the reconciliation and hopefully the data binding or the auto binding of functions. And then as Danny Abramov talked about yesterday, hot reloading doesn't work with stores. And he has a great solution for that that we'll probably look into integrating with Flexible as well. So in conclusion, the Flux patterns are simple enough to use on the server. And there are plenty of implementations out there that can help you get started. So I'd highly recommend that you look into, if you're starting a new app, if you need server rendering, before you jump into your architecture, try to figure out whether you need server rendering, and then choose an application structure that will allow you to do that. That's all I have. Thank you. So we have a website, Flexible.io, where we document all of our library. We also have, as I mentioned before, several examples. So I guess I can take questions on, I'm sure a lot of you have questions on our stack or our Flexible implementation. Okay. Oh, over here. Yeah. So the question is, does it handle multiple React instances on the page? And the answer is yes. I mean, this Flux architecture is decoupled completely from React. So you could have multiple React instances that use the same context. You could just pass it in at the top level. Or you could have multiple React instances with multiple contexts. It's really up to you. And you could also use it with something else if you wanted to use it with some other library. We're working on making sure that everything is decoupled from React so that you could use it with React Native, for instance. All right. OK, thank you, everybody.